So this problem's talking about smartphones. They're selling them at a price of $130 minus 0.05x, where x is the number of smartphones manufactured per day. Okay, so somebody came up with that price model. So I guess, the more you make per day, the less you have to sell them for. The parts cost $40, and the labor and overhead costs $6,000 per day. So that's maybe, it's paying people, that's paying for electricity for the building, things like that. We want to know how many smartphones should the company manufacture and sell per day to maximize profit. So this is one where it's good to kind of note what our variables even are. So again, X is number of phones made per day. Okay, and then as far as what we're doing here, what we're trying to do is maximize profit. Okay, and the equations we have, so profit, first of all, let's think about this. As far as a profit, you make money, your revenue is like how much you sell things for, revenue, but you have to subtract out your overhead. So basically, the money you make minus, so this is like money earned, and this is cost to earn it, essentially. Okay, so profit is revenue minus overhead. So in this case, our revenue, the money we make, so we're going to make 130 minus 0.05x, and we make that for each phone we make. Okay, so that's the price of each phone. And how many phones are we making? Well, X. So if you sell 100 phones, you'll make $100 times 130 minus 0.05 times 100. And our overhead, call this H for overhead, because I don't feel like writing OH. I could have written O, but we're going to go for H. Our overhead, well, it's $40 per phone. So it'll be $40 times the number of phones, and $6,000 per day. So plus $6,000, because X is not number of days. Our whole question is maximize profit per day. I guess I can add that back in there. Okay, so we're trying to maximize the profit we make each day. So in a given day, our revenue is the number of phones times 130 minus 0.05 times the number of phones, and overhead is 40 times the number of phones plus $6,000, because no matter how many phones you sell, $6,000. So then back to our profit equation, which is what we're actually trying to maximize. That's revenue minus overhead, so it's going to be X times 130 minus 0.05x minus our overhead, which is 40x plus $6,000. Because again, profit, if you think about it, like make $1 million, great. But if it costs you $1 million to do that, 1 million minus 1 million is 0. So profit is like the money you make after subtracting expenses. So now we can simplify this, or distribute, I guess, and then simplify. So this is 130x minus 0.05x squared minus 40x minus 6,000, which is, let's see, 130 minus 40 is 90x minus 0.05x squared minus 6,000. And again, we're trying to maximize profit, so this is literally the equation we're trying to maximize. So now P prime is 90 minus 2 times 0.05 is 0.1, so it's 0.1x. Let's we subtract 1 power, and then the 6,000 goes away. If we set this equal to 0, we end up with 90 equals 0.1x. Divide by 0.1 on both sides. So x is going to be 900. So here's our critical point. It's going to be 900 phones. And probably this is a maximum. It doesn't really make sense that that would be the minimum number of phones, but let's check it. So the second derivative is going to be negative 0.1. And so this is concave down, so this is a maximum. So it means whatever critical point we found was a maximum. And that's what we wanted. We're trying to maximize our profit. And so then our answer is that you should sell 900 smartphones per day. And that will maximize your profit.